Okay, welcome to AP Prob and Stat. The first chapter we're going to do, it's real simple. It's only, we're going to do it all in one day because it's a lot of vocabulary and a lot of the stuff you're going to see later. So we're just going to kind of roll it out all in one day. There will be a quiz on this at the end of the week, but it'll be super short. So, like I said, a lot of it's vocab, and we'll be talking about this throughout the whole year. So obviously the first word we need to talk about is what is statistics. So you're in AP Prob and Stat, but a lot of people just call it AP Statistics. It's the science of collecting, analyzing, and drawing conclusions from data. It's also the art of distilling meaning from data. We'll get to the distilling meaning kind of more second semester. So there's a few things that you need to kind of know in terms of the whole course. We have to talk about a population versus a sample. So the population is obviously the entire collection of individuals or objects about which information is desired. Now, a population does not have to be all people in the whole world. For example, it could be as easy as just PSEP students, if that's our population. If we want to talk about high school students or PSEP students, that's easy. We don't necessarily need like the whole world. When you study an entire population, it's called a census. Obviously, in the United States, we do a census every 10 years. So we recently just had the 2020 census, and a lot of things are made from that. Obviously, we can't do a census all the time. So then what we need to do is a sample. So a sample, this should be subset, is a subset of the population selected for study in some prescribed manner. We're going to talk about how you find samples throughout Chapter 2. So just know it's a subset for now. Descriptive statistics is the branch of statistics that includes methods for summarizing data. We sort of do that first semester. We'll talk about tables, graphs, we'll have pie charts, box plots, anything that's descriptive we look at in the first semester. Second semester is all about inferential statistics. Make sure I read this right. So inferential statistics is the branch of statistics which involves generalizing about a population based on information from a sample. So statistical data analysis is the process of drawing on these generalizations. We really focus on inferential statistics second semester. It's about 40% of the AP test. But for now, we're going to start with descriptive, and then we get to inferential later. Obviously, in this class, a variable, you guys have seen variables before. In other math classes, it might be X or Y. In this class, a variable is any characteristic whose value may change from one individual to another. So anything you're looking at, so height, weight, math class, doesn't necessarily have to be numerical, and we'll talk about that in a second. Data results from making observations on one or more variables. It is important to remember that a set of information is not data unless it comes in context. So in this class, pretty much every problem is a story problem. So you're always going to need to put things in context. Like you're never just going to tell me the answer is 12. 12 what? $12, 12 cents, 12 whatever. So it always has to be in context. A set shows the values of a variable can take and how often it takes these variables. Univariate data is what we're going to look at sort of first. It's a set that consists of observations of a single variable. So if I looked at everybody's height in this class, or weight in this class, or shoe size, that would be univariate. Bivariate data is two observations of two variables for each member of the sample. So height versus weight. We look at this sort of later like a scatter plot. That'll be in chapter 5. So univariate we start off with, and then we get to bivariate. So there are two types of data. There's categorical and numerical. So these are kind of easy to remember because it's like either it's a category or it's a number. A lot of books will call them qualitative or quantitative. You can just stick with categorical or numerical. Our book uses that, and the AP exam is totally fine with that too. So categorical data is if the individual observations are categorical responses. Oops, I spelled it wrong. So, for example, eye color would be one. That would be a category. Math class would be a category. It could be your actual grade in the class. Now, I know that could be like numerical, right? But it's also a category. So some categories do have numbers in them. There's one of the ones in the homework that is sort of tricky. It's like a number, but it's also a category. I won't give it away, though. Numerical is every observation is a number. Now, in this one, you'll see more numerical data, obviously. But there's actually two kinds of numerical data. So you can have a number count, or you can have a measurement. So for example, like test score, you might get an actual number, like I got an 89 or I got an 88. Whereas height, if I'm looking at inches, I could say I'm 5'4", or I could say I'm 5'4 1/4. I could keep going down. So there's two kinds of different numerical data. So that's kind of what's on the next page. So you have categorical data, you have numerical data. So there's two types of numerical data. So continuous data is when the set of possible values forms an entire interval on the number line. So, for example, anything that you can keep counting. So time, distance, any sort of measurement would be continuous. You guys have seen these like in algebra where it's like, from 0 to 2, including 0 but not including 2. So you've seen intervals before. So anything that's an interval is continuous. Discrete, think of isolated points on a number line. So for example, goals in a soccer game. Number of retweets. So anything where you're counting. So think counting. So continuous is more of a measurement, discrete is more of counting. So example 1, there's determinant for the following variables are categorical, or you can just stick with numerical. If they are numerical, tell me if they're continuous or discrete. So go ahead and try and do that on your own. Pause the video, and then when you come back, we'll go through the answers. Okay, so here are the answers for example number 1. I'm going to flip papers. So, number of insufficient fund checks received by a grocery store during a given month, that would be numerical, that's discrete, because you're counting the number of checks. The amount by which a 1-pound package of ground beef decreases in weight before purchase, that should be numerical, but it's continuous because it's a measurement. Science courses taken by students at Salem High School. that's going to be categorical. Number of New York Yankees during a given year who will not play for the Yankees next year. Again, you're counting, so that's numerical discrete. The price per gallon paid by the next customer that buys gas at a particular gas station. That's going to be numerical. It is discrete. Now, a lot of people kind of like to fight me on this one, but at a gas station, when you're paying, you're only paying like $1.21 or $1.22. Like when you pay at the gas station, they round it to the nearest cent. So even though it could be considered continuous, it is discrete. So money is always discrete because you're always rounding to the nearest penny. Color of pants worn by students in AP statistics, that is categorical. Okay, so on your quiz in chapter 1, usually there's a section where you have to kind of go through and do this. Okay, so moving on to example 2, what we're going to do, we're going to use a frequency distribution, which represents the graphs or the grades of random sample of math students. So we're going to make a bar chart and we're going to make a relative frequency bar chart. So you're going to be making a lot of graphs in this class. So in this class, every graph needs to have a few things. First of all, you need to have a title, because in this class, context is always very, very important. So you need to have a title. Then you need to label the X and Y axes. Okay, again, context. Now, if you're just doing univariate, you may just have to label the x-axis, but you do need to label both. And then you need to have an appropriate scale. Usually the AP exam will give you some sort of like graph like this, grid, whatever, and then you can go from there. But you need to have some sort of scale. Our graphs do not always have to start at 0. Okay? So the first one we're going to make is a bar chart. Now with the bar chart, I need a title, so I'm just going to make it simple. This is just going to be math grades. Okay, no need to be fancy. We're just going to make it simple. So I have A, B, C, D, and E. Okay, so for a bar chart, we're going to do just the frequency. So my y-axis is going to be the frequency. And since I have to go all the way up almost to 500, I'm just going to make each row 50. So this will be 100, 200, 300, 400, 500. Now, in a bar chart, we're going to need some space in between the bars because technically these are categories. So I could flip them in any order. Now, I'm obviously going in numerical, but I could go backwards. This is going to be grade. So I'm just going to make my A. I'm going to go all the way up almost to 500, and I'm just going to stop. I don't have a ruler. So that's my A. B, 293. Stop it short. C is 113. And you're just estimating. D is 35. And then E is 32. Okay, and then you can kind of shade it in because obviously you won't be able to have like colored pencils or anything. So shading is fine. Now relative frequency. So the difference between a regular bar chart and a relative frequency bar chart. Relative frequency is just a fancy word for give me a percent. Okay, so total I have 927 in my sample here. So everything's pretty much going to stay the same. The title is going to stay math grades. But this is going to be relative frequency. And then I have A, B, C, D, E for grades. So you want to find the percentage. I don't know where my calculator went, but that's okay. So I'm going to go up by 10. And you don't necessarily have to go up to 100 because obviously total all of this is going to be 100. Like for the A, we're going to go just under 50%. So you could just go up to 50 and it would end up looking the same as this. But I just kind of put it up to 100. So An A grade is just under 50%. A B grade is just above 30%. A C grade is just above 10%. A D is about 8%. And an E is slightly under that. So you still sort of get the same total look, but obviously we're using percentage versus frequency. Now, a lot of times with relative frequency, you don't necessarily have to put it as a percentage. You can just do 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. You get the idea. So some books will have it as a percentage 1 to 100. Some will have it as 0.1 to 1. So it doesn't really matter. I don't really care either way. I'll get the gist of it. Okay, and then the last one we're going to look at is a dot plot. So this is another univariate. Everything we're doing here is univariate. We're only looking at one thing. So here we have highway gas mileage for a model year 2000 midsize cars. Construct a dot plot to display this data. So with a dot plot, we're going to put mileage and miles per gallon down at the bottom, labeling our axes. Now for your title, again, you don't have to be fancy. I'm just going to say highway gas mileage for year 2000 midsize car. Okay, and then every time you see miles per gallon, you're going to put a dot. Now the lowest is 21 miles per gallon. So I'm going to start there. The highest, I think, is 32. But we're just going to keep going. So this is obviously more of discrete data. So this is numerical discrete because we can put dots on a number line. And even though the highest is 32, I'm still going to fill in the last couple ones because it's on my scale anyway. So if you wanted to go underneath, you could do 20 to 35. But just make sure you have all of them on there. And then when you're doing the dots, you're just going to go through and as you do the dots, kind of cross them out. Make sure the dots are evenly spaced. You don't want 2 dots in the same amount of space as you have 4 dots somewhere else. Because then obviously it won't be a good comparison. So just kind of go through the table yourself and put a dot on each one. Again, evenly spacing them. I kind of cross them out as I go. And then you can kind of see where the most frequent ends up. And we'll do more with this stuff as we go through the year. This first week is really just an intro. And you can do a couple at a time and then cross them out. But again, I like to kind of cross out as I go. All that. Okay, so there's your dot plot. So as you can see, I sort of made them all evenly spaced, and obviously it goes from 21 to 32, and we'll talk more about this stuff as we go on. But that's really it for chapter 1. So a lot of the stuff you sort of already know. You may have seen in other classes, so it's really nothing new. But like I said, the most thing I would focus on for that first quiz is maybe doing one graph and then knowing how to do the difference between categorical, numerical, and discrete continuous.